This data is also available for the United States, and so we can use data normalization not just to compare between demographic groups, but to compare between, say, political divisions. So the United States data is collected by a collaboration of researchers and data scientists, and it's available for download here. This website also has a visualization showing, obviously in enhanced speed, all of the incidents of police killings in the United States in 2020. And you can download the full database here. So, and this is a quote from the researchers that collected this data. They believe that this data represented on the site is the most comprehensive accounting of people killed by police since 2013 in the United States that's available. The mapping police violence data set is more comprehensive than the Washington Post police shooting database, because while the Washington Post only tracks cases where people are fatally shot by on-duty police officers, our database includes additional incidents such as cases where police kill someone through use of chokehold, baton, taser, or other means, as well as killings by off-duty police officers. So this data set isn't necessarily an official count either, as again, it's just a collection of secondhand information. Police departments in the United States are also not mandated to record and disseminate this information. So again, some of their records are incomplete and the total number of incidents are likely higher than detailed. However, this data set is collected by a nonprofit organization that is dedicated to this task. So it's one key advantage is this data set is updated on a monthly basis. It's not tied to the whims of the news cycle. And also because it's an open source data set collected by a collaboration of researchers and data scientists, they're more transparent with their methodology and definitions that they choose for what constitutes an incident of police violence. Whereas the CBC has been there's been a lack of transparency in regards to how they've made decisions with their data set, as I highlighted with the incidents of the Starlight Tours being omitted, for instance. So we'll just briefly look at the US data to compare. And obviously, right off the bat, you can see that there's much higher frequency or a higher number of police killings by year. There's over 1,000 incidents per year. And the United States is a much larger country than Canada. It has over 10 times the population. So you would expect this number to be higher. One thing I would like to point out is that there isn't a clear upward trend in the United States as there is in Canada. So the anomalous or the large uptick that is observed in recent years, especially in 2020 in Canada, has not been observed in the United States. So that highlights some really key significant issue that's unique to Canada as far as 2020 is concerned. You can see the age distribution of victims as well, along with the racial breakdown, similar to presented before for Canada. You can see again, and this is not normalized, just looking at the total numbers. You can also say white people are the majority of victims of police killing in the United States. But as with Canada, the United States has also got the demographic groups are not evenly distributed. There are more white people than black people. So again, you have to account for this. And then in the data set, they also have the distribution of whether or not the victim was armed. They don't detail the specific weapon type. But 21.6% of the victims in the United States were unarmed relative to over 30% of the victims of police killings in Canada. So from that, you can extrapolate that Canadian police are actually more likely to kill unarmed people than police in the United States. So if you want to compare these two records, if you just plot them side by side, Canada versus the United States, it just is grossly different because of the fact that the United States has a much larger population, but also these data sets aren't covering the exact same time. So the United States data set only goes back to 2013, whereas the Canadian data set goes back 2 decades. So this is not an effective or accurate way to compare this information. It would be really misguided for someone to just make this chart and say this is fact. It glosses over the differential periods of record and glosses over the differential sizes of the population. So we need to normalize these data sets. We need to take into account the population sizes of the countries and take into account the differential periods of record. So I've just given you the answer to question number 6. What factors do we need to look at to compare the rates of police killings between Canada and the United States? Again, check all that apply. Populations of both countries, the record lengths of both countries, socioeconomic circumstances, and the different rates of gun ownership in each country. Now, the different rates of gun ownership in each country likely has an impact on this number and may in some way have an impact on police predisposition to use force. But in order to compare the rates, you don't need to take that into account. You only need to look at populations and the time period. So if we normalize for both countries, we can calculate the police killing rate for Canada and the United States to do a more direct comparison between geographic regions with different characteristics, that being different populations, and data sets of different lengths. So police killings in the United States are, police in the United States are, on a whole, more likely to kill someone than Canadian police. However, again, this doesn't tell the full story because systemic racism is pervasive on both sides of the border, and there are severe racial disparities in both countries. So we really need to break down by demographic group for each country to look at things more in depth. So the police violence data sets for both countries and the census records for both countries use different demographic groupings for some people. So we can't directly compare between all groups. However, 3 demographic groups, white, black, and indigenous, are recorded by both the Canadian and United States census and both of the police violence data sets. So we will just stick to comparing between these 3 for now. So white people make up the majority of the population in both countries, while black and indigenous people are disproportionately impacted by police killings on both sides of the border. So one caveat here is that the race of the victim is unknown for 25% of the Canadian incidents, whereas it's just 9% for the US incidents. So this does add some uncertainty to this analysis, and it means that the police killing rates by race are underestimated for both countries, but especially in Canada relative to the United States. So this graph is just showing, again, the normalized rates for the total population, and then white, indigenous, and black individuals. And we can see that indigenous and black people are much more likely to be killed by the police than white people in both Canada and the United States. And you can see that the overall rates for each racial group are higher in the US than they are in Canada. But this is still not really telling the full story. And you can also see that the rates for black and indigenous individuals in Canada are comparable to or higher than the rates for white individuals in the United States. But this isn't really telling the full story yet. We can do a little bit more to highlight the issue of systemic racism in Canadian policing. And you can tell just by looking at it that the relative proportion for, say, a white and indigenous individual in the United States, the relative difference between a white and indigenous individual in the United States versus the relative difference between a white and indigenous individual in Canada is different. You can see just by looking at the magnitude of these bars, but again, we want to get this into one concise number or statistic that can be more accurately and easily presented. So we can normalize the data again. We can divide the Black and indigenous rates for each country by the white rate for each country. So again, we'll just normalize that data again. So we're taking a normalized statistic and normalizing it again. There are multiple different adjustments you can do to account for the correlation and relationship between variables. And so what this will do is this will tell us how many times more likely a Black or indigenous individual is to be killed by the police than a white individual in each country. And so in doing this, we can see that indigenous and Black Canadians are 6.3 and 4.4 times more likely to be killed by the police than a white Canadian. So these disparities are much, much higher than they are in the US. And so what this highlights is that even though the United States has a higher overall rate of police killings, that even though the police in the United States are more likely to use force, more likely to use violence, more likely to end up killing someone, the relative likelihood that police in Canada are going to use violence on an indigenous person versus a white person is much, much higher in Canada than it is in the United States. So by this metric, you could say that Canadian police are actually considerably more racist, or systemic racism is more ingrained in Canadian policing than it is in the United States. So this is just one metric, one way to look at it, but it really highlights that there's a grossly disproportionate overrepresentation of Black and indigenous individuals as far as victims of police violence go in Canada. And so just like to take that into account when thinking about the answer to these questions. So I asked you at the introduction what your thoughts or your opinions were on this, and now 7 and 8 have actual answers as presented here. So again, which country has the higher frequency of police violence, and which country has a greater racial disparity in incidents of police violence. And I would just like to point out, just mention brief history of policing in Canada, because again, this issue is not restricted to the United States. It's just as pervasive in Canada, and it cannot be overlooked. So the RCMP were initially created by Prime Minister John A. Macdonald. He got the idea for the Mounties from what's known as the Royal Irish Constabulary. That's a paramilitary force that was used by the British to keep the Irish under control. So the Northwest Mounted Police, or the RCMP, were initially called the Northwest Mounted Rifles. And their primary purpose was to clear indigenous people off of their land to make space for westward expansion and the railroad. The name was changed to the Northwest Mounted Police, not because of concerns that might encourage, say, military action, or not because of concerns about how that might be perceived within Canada, but because officials in the United States raised concerns that an armed force along the border was a prelude to a military buildup. So the only reason they even changed the name to police was because of how it might be perceived in the United States. The organization was renamed the Royal Canadian Mounted Police in 1904. And if you want to learn more about the history of the RCMP, I suggest you listen to this podcast by The Secret Life of Canada. It goes into the history of the RCMP and how systemic racism was really baked into their mission statement from its inception and how that has continued into present day. So now that I've talked about the importance of data normalization and shown how it can be used to highlight trends and patterns that might be hidden or conflated with another trend or pattern, so police violence relative to total population, I want to shift gears and talk about data classification. I'm going to talk a bit about histograms, different classification schemes, and chloropleth mapping. So you've gotten an introduction into data normalization in Lab 3, and you're also getting an introduction to different classification schemes in Lab 3. So I want to talk more about those schemes and what we can do with them. So before I get into that, I just want to mention the concept of different data types. And so I talked about that in lecture the week before reading break. But just for a refresher, there's two kinds of data. We've got, and each type has two subtypes. So there's qualitative, which is descriptive data, and that includes nominal and ordinal data types. Nominal data is categorical data with no inherent ranking. Ordinal data is categorical data that does have a ranking. And then we've got quantitative. So that's numeric data, and that includes ratio and interval data. Interval data is similar to ratio data, but it lacks an absolute 0 point. Ratio data has an absolute 0 point, and the differences between values are meaningful. The police killing rate is ratio data because it can't be negative, and a police killing rate of 2 is twice as high as a police killing rate of 1. So if you need a refresher on the differences, I suggest you go back to the week 5 lecture and look at the video on data type. So as I mentioned on the introduction page, histograms are pretty important when looking at data. So we can normalize our data by demographic information at different administrative levels. So say we want to break things up by province/state. So what I've done here is I've merged the data for the US and Canada together just to have a larger data set to look at. So we can calculate the we can calculate the police killing rate by province and state, break that up. So we'll have 63 records, 15 for US, or 50 for the US and 13 for Canada. So we're looking at provinces and states and territories. I guess we have 66 records. And if we want to classify these rates, right? So again, we've got 66 records, but that's a lot to look at. We want to classify it. We want to condense it into a smaller number of classes so it's easier to interpret. The first step in that is to look at a histogram. A histogram shows us the frequency distribution of a given variable. So again, data is just grouped into a set of bins and counted. So this, for instance, is the, looks like my units are off here. I'll need to fix that. But it's just showing the police killing rates by province or state per year. And you can see that most of them are grouped towards the lower end, and then there's some higher outliers. So outliers are a really important thing to think about. And histograms can be really useful for spotting outliers in a data set. So whenever you're plotting data, it's always a good idea to look at the histogram. And there's functions in ArcPro that you can use to quickly generate a histogram for a distribution. So for instance, this histogram is showing two different groupings. the police killing rate for indigenous individuals in the United States. And so you can see that the light red is showing all the data. You see there's this one outlier here where the police killing rate per million residents per year is nearly 70. And that turns out to be Vermont. But if you exclude Vermont, we see the distribution of the data set looks much different. And so the reason behind that is that Vermont has a very small population in general, but a very, very small indigenous population. There's only about 1,000 indigenous individuals that live in Vermont, according to the census records. So even though there was only one incident in Vermont in the last 8 years, because that's being normalized by such a small population, it creates an outlier. And so it's just something you have to think about when conveying and displaying your data. Sometimes the best plan of action is to display the outlier, be upfront about it, and explain it. Sometimes the best plan of action is to remove the outlier from the data set so that it doesn't skew the distribution. And I'll come back to that in a bit. But we're going to cover 5 different classification methods. So you've worked with some of these in Lab 3 already, and all of these are options within ArcPro that you can use to classify your data set. So I'm just going to talk a little bit about each one to show how they can highlight different patterns or mask different patterns within the data set. So the first one we're going to talk about is equal interval. So with this, data is split into bins of equal width, regardless of the distribution of the data set. So you take the maximum value, the minimum value, and you say, okay, I want 5 bins. You take the range, say the maximum value for this data set is 10.6 and the minimum value is 3.3. So you just divide that range by 5 and you get the width of each bin. With quantiles, you split the data into percentiles. So the only thing you decide is how many bins do you want. Say 5. If you want 5 bins, you'll split the data into 0 to 20%, 20 to 40, 40 to 60, so on. Natural breaks. This is where the data is split using something called the Jenks algorithm. So this is an algorithm specifically designed to maximize within group similarity. And so it looks for natural breaks in the data set. And then there's manual breaks where we can define our own splits. And so you worked with that in Lab 3 quite a bit. And then there's standard deviation, which you haven't been exposed to yet. And so here data is split into bins based on the distance from the mean. So before I show you the different classification methods, I would just like to make a note on color schemes. So sequential color maps are the best choice for representing ratio data. So that's something like the police killing rate. So I suggest you check out this tool called Color Brewer for help picking out color schemes. It's pretty neat. You can say, oh, I want 4 classes. I want this color scheme to be colorblind safe. And then you can pick whichever scheme you want from there. There's multiple different options. And you can say whether you want sequential, diverging, or qualitative color maps. And so I'm going to go into a lot more detail next week about some different design principles, and color is one of the important ones to think about, but I just wanted to mention that Color Brewer is a good tool for picking colors. So to start with, we'll look at the equal interval classification, right? And so we can see the minimum value is 0.33. That's at Prince Edward Island. And the maximum value for the data set is 10.6 in Nunavut. So we can take that and we can see that we'll split the data into 4 bins, or 5 bins, at 2.6 wide. Excuse me. So we can see here, I just want to point out that Nunavut has the highest police killing rate of any administrative subdivision in Canada or the United States. And the numbers presented here are even contradicted by the CBC's own reporting, which suggests that the death rates may be much higher across all of the North than is presented here. So there's been a separate data set collected by the CBC that looks at police-involved deaths. So they use a slightly different definition of what constitutes a police-involved death here. And this data set has not been released to the public, so more work needs to be done to figure out what's going on with the discrepancy between this data set and the one that's available. But even just using the data that is presently available highlights that Nunavut has the highest police killing rate in the United States or Canada. And it's not a coincidence that Nunavut is approximately 75% Inuit. So it's got the highest, far and away the highest Indigenous population in the country. And so with the equal interval class, we can plot the histogram, and we can just look at the way these intervals are split, and we can see that they're evenly distributed across different groups. And when you look at the map, it does highlight the severity of Nunavut, for instance, but one issue with using this equal interval classification is it really masks the variability across Canada and kind of minimizes the pervasiveness of the issue across most of Canada. And again, that's because we're not taking into account the distribution of the data set or anything. We're just going from the maximum to the minimum and going with simple splits. Now we can do something different. We can look at quantiles. This is the simplest classification scheme that's based on the distribution of the data. So here the data is ranked and then broken into percentiles. So class 1 contains 0 to 20%, class 2, 20 to 40%, class 3, so on and so forth. And so you can see the class breaks here are quite different relative to the class breaks, especially for the lowest values for this data set. And so this highlights, for instance, that British Columbia has the highest police killing rate of any of the provinces in Canada. And so this highlights more of the variability within Canada. And you can see the break values and where they correspond to on histogram are different because they're counting for the distribution of this data set. The natural breaks uses the Jenks algorithm. I believe I just linked to the WikiGIS page. So I encourage you to take a look at this page to get, I'm not going to go through it all, but just to get a feel for what the natural breaks algorithm does and how it works. You don't need to be able to explain how it works, just get a rough idea of what's going on here. And so again, you can see the break values here are also different than they are in the equal interval and than in the quantiles. And you can see that the way this algorithm displays the data versus the way quantiles display the data highlights different patterns in both the United States and Canada. And so the goal of the Jenks algorithm is to maximize within group similarity and maximize between group dissimilarity. And you can see how the groupings look here. Perhaps a better choice in many circumstances, but it requires you to be more familiar with the data you're looking at, is manual breaks. So we can use manual breaks to define our own break values to classify the data in a way that we see fit. So this allows us to choose more meaningful break values if necessary, so things like round numbers or clean fractions. And the choice of, one key caveat here is that the choice of manual breaks can influence the way we perceive the data. So whereas natural breaks and quantiles are somewhat objective in that we're not actively making much of a decision here besides how many classes to choose, manual breaks, we're actively thinking about how we want the data to be seen or perceived. So in one regard, it can impact the way people take in the data. And so I don't say that meaning that it's good or bad inherently. I just say that meaning that it's important for one to take into consideration when designing a classification scheme. So for instance, we can manually assign our break values of 0 to 1, 1 to 2, 2 to 5, 5 to 10, 10 to 15, for instance, even though none of its values 10.6. So this leaves none of it alone in its own class, highlighting that none of it, for instance, has far and away the highest police killing rate in either of the two countries. But this also highlights that police killings in Western Canada are higher than they are in Eastern Canada, for instance. And again, we can see where are these break values lining up on this histogram. And then there's the standard deviation classification. And so this distribution is a little bit different. This distribution is based on how far any given value is from the mean of the full data set. So it can be really informative to a knowledgeable user. It shows the relative difference. Okay, like Canada is below the average. All of the provinces and territories, except none of it, are below the average for the aggregate data set. And it can show spatial patterns and where is above and below the mean. But it's not particularly accessible for the general public. So this is not something that you would want to use in like a newspaper article or something that's going to get posted for wider dissemination. It's more for an informed user base. The standard deviation classification method converts data to interval data. So deviations above and below the mean. So this isn't a ratio data set. And diverging color maps are a better choice for interval data in many instances because it highlights what's above versus below the 0 point. So again, Color Brewer has choices for that. What I mean by diverging is, say you've got red on one side and blue on another. And again, I'll cover more of this when I talk about design principles next week. So just some poll questions to think about. If you want to highlight the severity of systemic racism in policing, which classification method do you think might work best? There's not a right or wrong answer here. Again, just kind of a matter of opinion. I just want to see what folks think about this. And then 10, and this highlights some of the ethical issues with data classification methods because it can be used for nefarious purposes. What classification method might the RCMP choose if their goal was to minimize the severity of systemic racism in policing or minimize the severity of police killings in general? So just a little bit more to wrap things up. I want to talk about the other data types, ordinal and nominal. Ordinal, again, is just ordered categories. So ratio data can be translated, for instance, to ordinal data and used in a descriptive sense. And so again, sequential color schemes are also a good choice for ordinal data. So the following is an example of ordinal data with a really poor choice of category labels. So I've just converted this, classed it into 3 groups that say low, medium, or high. But what does low, medium, or high mean? Low or medium relative to what? So if you're going to use ordinal data, it's important to give some more context or description. So we can give an example with more descriptive labels. For instance, categories could be, instead of low, you could say the police killing rate is less than the Canadian average, the police killing rate is less than the US average, or the police killing rate is greater than the US average. That would be more descriptive, and it would show relative to some more concrete example. And then we've got nominal data. So this is categorical. Race, for instance, is a categorical variable. There is no ranking. One is not more or less than the other. They are just different categories. And so a nominal variable can take one of a limited number of possible variables, assuming each record in a assigning each record to a nominal category on the basis of some qualitative property, so some quality. There's no inherent numeric aspect to it. So when working with categorical data, you want to avoid sequential or diverging color maps, as those can give the impression of ranking within the data. So you want to choose a categorical color scheme instead. So that would be qualitative. And so instead of having rankings of colors, there's just groupings of colors that are different. So for instance, this map is showing categorical data, just showing the race making up the largest number of police killings in each province or state. And so again, this data is not normalized. This kind of goes back to that point that I highlighted earlier, where someone's saying, oh, the majority of victims of police violence are white. If you just take that at face value, this is what you end up with. This is based on the number of victims of police violence per demographic group without accounting for the demographics of the actual population. And so a more accurate way to represent this data would be to account for the differential population numbers. So we could say, instead of what race is the majority of police killings, we could say what race is most likely to be killed by the police. And so this would be for each administrative division, which demographic group has the highest police killing rate. This is the highest number, and this is the highest rate. So this is the difference that data normalization makes. So you can see that when you normalize the data set by demographics, it reveals that across the majority of Canada and northwestern United States, Indigenous individuals are most likely to be killed by the police. Across the majority of the United States, along with the province of Ontario, Black individuals are most likely to be killed by the police, whereas white individuals are only most likely in a few states and one province. And so this is a nice visual example of the importance of data normalization and how, one, data normalization can be used to highlight patterns that aren't immediately available in a data, or aren't immediately obvious in a data set. Also, two, how the lack of normalizing data can really grossly misrepresent patterns in a data set. So when you're taking a variable, you really need to, and you're displaying it, you really need to think critically about what are some other things that this factor might be conflated with, and how can I adjust for that? And so poll question number 11 is just, which map gives more truthful representation of the data? And again, yeah, just sort of an opinion-based question, even though there is essentially a right answer to it. So the first 11 questions in the week 6 quiz are related to this webpage. They're just like pretty straightforward. You're just going to get the right answer for filling it out. I've got 7 or 8 questions after this that are survey/poll questions. I really just want to get a feel for how people are doing in class this semester, get a feel for what folks think is working, what's not working, and there's space for open-ended entries. If you have any questions or if you have any criticisms or suggestions of things that I can do to help make this course work better for you. So I'd really appreciate it if you all filled out the survey and just gave me a bit more information so that I can try and adjust things as needed.